All right. So again, this is 8.3b. Just to finish to our notes. We worked with hexagons yesterday. Now, the process I'm going to go through here will work with any polygon, okay? Any regular polygon. This will work with any regular polygon, okay? Now, the goal, like we were working on in our Desmos activity, is to find the perimeter and the apothem, because those are the two things we have to plug in to solve for our area, okay? Now, the way I can do that is if I focus on this right triangle right here, there we go. If I focus on that red right triangle, if I know the two legs of that right triangle, I can figure out the apothem and the perimeter. Okay, so I'm going to focus on that right triangle. Now, in order to do that, I need to know some other parts of that triangle. Okay, now in this case, we're given a side length. Okay, we know that each of these sides is equal to 8. Okay, I'm going to redraw this red triangle out here just so it's a little bigger. Well, if the full side length is 8, I know that the apothem does two things. It divides the side length into two equal segments. So the full side is 8, then half of the side is 4. And the other thing I know that it does is it takes the central angle that this big triangle is made up of, and it divides that angle in half. It's an angle bisector as well. Now, if you guys remember from yesterday, the way that we find the central angle that one of these triangles makes is we do 360 divided by the number of sides. In this case, it's 5. That means each one of these central angles is 72 degrees. Okay. Now, again, I want to focus on that, just this right triangle over here. Okay. Well, that one's going to be, that angle up top is going to be half of 72, which is 36. Okay. Now, this big triangle I kind of redrew over on the right-hand side here. I have all the information I need to find the perimeter and the apothem. Okay. Now, I had to figure out what that angle measure was, and I had to determine that half of the side length was 4, but I now have enough information. Okay. I can't use Pythagorean theorem because I don't have two sides. Right? I can't use special right triangles because there's no 36, 90, what would that be, 54 degree special right triangle ratios. We don't have those. So we have to use trig. So 36 degrees is my angle. So I label my sides, opposite, hypotenuse, and adjacent. I'm going to name this left-hand side. I'm going to give it a variable of A because it's the apothem. So if I want to solve for A, I'm going to use the opposite and adjacent sides, which is tangent. So tangent of my angle, 36, equals opposite over adjacent, TOA. So opposite over adjacent, so 4 over A. Variables low, switch them no. So A equals 4 divided by tangent of 36. That's what my calculator is going to help out with. 4 divided by tangent of 36. I get 5.505527 long decimal. Okay. My apothem is going to be about 5.5. Okay. We allow you guys to round a lot of these decimals to nearest 10th. Okay. We understand that that's going to give us a little bit of variability depending on where you round and when you round. So we know our answers, our final answers may be a little bit higher or lower depending on that. But in this case, the apothem is about 5.5. All right, let's plug into our area equation what we know. The area is going to equal 1/2 times the perimeter. Well, a side length is 8, and there's 5 sides. 8 times 5 is 40 times the apothem, 5.5. We're gonna plug that in to get our area. And in this case, because of how we rounded, our final answer is a whole number. It's 110. Okay. If I would have left that big long 5.5055, if I would have left that as kind of exact and kind of gone from there and multiplied that times the 1/2 times 40, I'd get 110.1 rounded in there as 10. So you can see how there's a little bit of kind of, we'll call it an error. Okay, there's a little flexibility within our error there. And we know that when we plug it into the system as far as what we're going to accept as correct answers. All right, so as long as you're doing the process correctly, your final answer should be good. Okay. All right, so the steps that we took there to solve for our area, you can use these again. If I had a 20-sided polygon, I could do the same thing. I'm going to be focusing on this right triangle here that I redrew. Right? It's just my angle would be a lot smaller because it's got 20 sides. So I do 360 divided by 20, which is actually 18. Right? And then 1/2 of 18 is 9. So this angle would actually be an angle of 9. We could actually use the same process using trig to solve for our side length and our apothem. Okay. Now, the way I went about solving this one is how you would do it if you were given a side length. Okay. So the examples that I'm going to talk about from your assignment are going to be one where we're actually given a radius and one when we're given the apothem. Okay. So let me go ahead and share that assignment with you guys. So you're going to need your Chromebooks out because it's another Desmos assignment. All right. We're going to go over number 5 first, and then we're going to go back and do just one part of number 2. Okay, 5 and then 2. So we're going to start on number 5. So if you guys, once you guys log into that assignment, just move on to number 5 there. While you guys are doing that, I'm just going to make sure things are in the right place. All right. Again, as I mentioned yesterday, the kind of the space that you have provided to draw in Desmos, well, I love you can draw there. It's probably not big enough to do the whole problem. Okay, so a separate sheet of paper is going to help you out. Okay, again, like before, I'm going to focus on this triangle. Okay, a triangle that's that right one. Okay, because I know that if I can find the apothem and that portion of my side, then I can find the perimeter and the apothem and plug them in. Okay. I'm going to go ahead. Again, I'm using some of my smartboard tools, so you guys won't be able to draw over here, but I can to redraw this triangle. All right. So this is what we know right now. This is all we know right now. Okay. Now, I also know that, or what I can find here, is there's a central angle, which is 360 divided by the number of sides. In this case, there's 8 sides. So if I do 360 divided by 8, that gives me 45. So this central angle is 45 degrees. But again, I want to focus on the one on the right. So that's half of 45, which is 22.5 degrees. Okay. So the triangle we're working with has a 90-degree angle and a 22.5 degree angle, and the hypotenuse is equal to 10. So if I gave you guys this triangle and I said, find your 2 missing sides, we would use trig. Now I'm going to label these with some letters that are making more sense to us. This leg here I'm going to name A because that is the apothem. This leg down here, I'm just going to make that X. Okay. So we need to find the apothem and the perimeter. Okay. Well, let's find the apothem first. So again, there's our angle, opposite, hypotenuse, adjacent. In this case, if we're solving for the apothem, we need to use the adjacent and the hypotenuse side. We have to use the hypotenuse because that's the only side that's given a value. So if we're using adjacent hypotenuse, that's going to be cosine. Cosine of our angle, 22.5, equals adjacent over hypotenuse, A over 10. Variable's high, so we multiply. Justice, can you see okay? Yeah. So A equals 10 times cosine of 22.5. That's what we're plugging into our calculator to get our apothem. 10 times cosine 22.5, 9.2387. Again, we're told round all answers to the nearest 10th, so I can round this answer to 9.2. All right, so 9.2 for our apothem. The perimeter. Now, there's no one step that's going to give me my perimeter right away, okay? But if I solve for x, then x represents half of a side length. Yes?
So you said earlier that they're equilateral triangles.
Oh, no, and that's why we have to use trig in this case. Equilateral triangles only happen with our hexagons. Yep, because when we find the central angle of a hexagon, that's a 60-degree angle, which makes all 3 angles 60. In this case, our central angle here we figured out was 45. So we divide it. So that's not unfortunately, it doesn't work out. And even though it is 45, it's not a 45, 45, 90, because the central angle is 45, not the 2 angles that are part of the right triangle. Good question. All right, so if I'm going to solve for x, I need to kind of shift which 2 sides I'm using for my trig. Well, let me back up a second. Is there another way to solve for x? What's that? Yeah, we just solved for a side length. So we now have 2 of the 3 side lengths. We could use the Pythagorean theorem. Okay. Personally, I prefer using trig twice because it goes a little bit quicker when you set it up and plug it in your calculator. But if it makes more sense for you guys to use the Pythagorean theorem, we just solve for this length. So now we have 2 of the 3. We could set it up and use the Pythagorean theorem. Okay. I'm going to use trig, but I have no problem with using Pythagorean theorem. I'm still going to use this angle. We're now solving for x. And I'm going to use this side still, the hypotenuse, because I know that it equals 10 exactly. So in this case, we're going to use opposite and hypotenuse, which is sine. So sine of our angle, 22.5, equals opposite over hypotenuse, so x over 10. Variable still high, so we multiply. X equals 10 times sine of 22.5. 10 times sine of 22.5. 3.826. All right. And this is where I want to show you guys how there's, because it's asking for the perimeter. Now, I could round this to 3.8, right? So I could say, all right, this side is 3.8, which is half of the side length. So I could double that. So 3.8 times 2 is 7.6. So full size 7.6. There's 8 sides. Times 8 is 60.8. Right? That'd be my perimeter. Let's put that in there. I'm going to show you guys how there's basically a couple of different answers here. 60.8. All right, now to find my area, we've got to do our area equals 1/2 times the perimeter, 60.8 times the apothem, 9.2. 0.5 times 60.8 times 9.2. I get 279.68 or 279.7. Check my answers. They say they're all correct. Okay. Now I'm going to back up a step. Now, when I solved for x, I got 3.8266882683432. So the exact answer is a decimal that goes on forever. If I were to take that decimal and multiply it times 2, okay, I now get another long decimal for my side length. If I multiply that long decimal times 8, because there's 8 sides, I get a perimeter of 61.2, which is different than what I got here. Okay. It's still correct. If we're allowing you guys to round, then we have to give you that flexibility. So that's why we understand why the answers may be a little different. Okay. So 60.8 is correct if you're rounding to 3.8 here. If you wait around until you get the perimeter, then the answer would actually be 61.2 for my perimeter, which is also going to change your area. Okay, it's going to make your area big. But again, when it comes to rounding, that's why the earlier you round when you're solving problems, the more variation your final answer is going to have. Okay, because of the rounding, right? There's probably some engineering disaster stories you can find because somebody rounded really early in the process. So it made something a lot further apart than it should have been at the very end. Okay. But for our purposes, we want you guys, we're testing to make sure you understand the process of solving for the area. So we're going to give you guys some flexibility. Okay. All right. Last one, number 2. I want to go over just one part of number 2. Because it's different than anything we did yesterday, right? The apothem they ask for, that's pretty straightforward. We're good on that. That's going to be equal to 8. part in this one is the perimeter, because it says for area, or what does it say? For the opossum answer in simplified radical form, for the perimeter, they want you to put the perimeter in simplified radical form. Okay, it doesn't say it in the directions, but that's what, it marks it wrong unless you put it in simplified radical form. And solving this one in simplified radical form it takes some steps. So let's look and see why that happens, okay? I'll focus on this blue triangle on the left. I'm gonna redraw it here. All right, so we know that that is 8. In order to find the perimeter, okay, we need to solve for this length right here. Now, this is a hexagon. So I know that these angles, and I didn't draw up the scale, are 30, 60, and 90. So I can use my special right triangles. And if they want you to answer in simplified radical form, it's probably best to do. So A, 2A, A radical 3. All right. Here's my equation. A radical 3 equals 8. To solve for A, I have to divide both sides by radical 3. You guys can probably already see why this one's a little more confusing. A is going to equal 8 over radical 3. Well, we don't like radicals in the denominator, so we have to rationalize it. Multiply top and bottom by radical 3. We get 8 radical 3 over a radical times itself just gives you what number is under the radicals, 3. This is A. So, and remember, what we're solving for here is half of a side length. Okay, so if I want a full side length, I have to double this. Right? So 8 radical 3 over 3 times 2. So this length is 8 radical 3 over 3. Well, if I multiply that times 2, I get a full side length. Okay. And again, if you want to write 2 as a fraction and multiply straight across, you get 16 radical 3 over 3. And if I want to know my perimeter, I have to multiply that side length times 6. Well, 6 times 16 is 96 radical 3 over 3. Now, that answer is correct. The 96 over 3 actually reduces, so we can make this look a little cleaner. 96 divided by 3 is 32. Okay, so my perimeter would be 32 radical 3. All right, this one is, we don't ask you many questions that require you to do the perimeter in simplified radical form, but this is a situation where it may be asked of you, okay? From there, I think you guys can find the area, okay? All right.